Now let's switch gears a little bit and talk about some code smells that occur when you're making changes to the code. The first of which is called divergent change. The divergent change code smells occur when you have to change a class in many different ways, for many different reasons. This closely relates to the large class, or God class smell. When you have a large class, it will have many different responsibilities. These responsibilities may need to be changed in a variety of ways, for a variety of purposes. So, poor separation of concerns is a common cause of divergent change. It would be nice if your class only had one specific purpose, as it should. This would reduce the number of reasons the code would need to be changed, and as a result, reduce the variety of changes that you would need to implement. If you find that you're changing a class in multiple ways, that may be a good indicator that the responsibilities of the class should be broken up into separate classes, and these responsibilities should be extracted into their own classes. The original large class would then delegate the responsibilities to these extracted classes. You've now resolved two code smells, large class and divergent change, with one design principle, separation of concerns. On the flip side, suppose you want to make one sort of change. You want to implement one small requirement, one sort of change. It would be nice if that change was in one place. You can't always do this, but it would be nice if it were localized. But say you wanted to make a change for a requirement, and it required you to touch a whole bunch of classes all over your design just to do that thing. Maybe that wasn't so great of a design. This code smell is called shotgun surgery, where, to make a change, you have to take a shotgun to your code and then deal with all the splatter effect. Violent, I know. We didn't name these smells, we're just presenting them to you. This is a commonly occurring smell. A change in one place requires you to fix many other areas in the code as a result. This could happen when you're trying to add a feature, adjust code, fix bugs, or change algorithms. Ideally, you want your changes to be localized, but that's not always possible. A change that only affects one or two classes is way better than a change that affects multiple classes. If you have to make changes all over your code, chances are you're going to miss a change or create issues elsewhere. Having modular code, though, is not always an option. There are sometimes changes that require shotgun surgery, no matter how well designed your code is. For example, say you need to update the copyright statement or licensing. You're going to have to change every file in your system to change a block of copyright text. You can normally resolve the shotgun surgery smell by moving methods around. If you find that a change requires you to make changes to many methods in many different classes, then that can be an indicator that these methods may be better consolidated into one or two classes. That's not to say, though, that you should move methods into one class so that you only have to make changes in one class. That's the large class code smell again. You should move them if it makes sense to. The fact that a change in one place leads to changes in other places does show that these methods are related in some way, so perhaps there's a better way to organize them. However, if it makes more sense to leave them as they are, then you may just have to deal with it the way it is. The next code smell we're going to talk about is feature envy. Feature envy occurs when you've got a method that is more interested in the details of a class other than the one that it's in. This sounds like a romantic movie. Long-lost lovers who end their relationship years ago are still in love with each other, despite being in new relationships. They're more concerned with the other's relationship than they are with their own. You, as the viewer, are just screaming at the scene that they should end their respective relationships and just be together. They're just never going to be happy until they're in the same place. Well, the solution is the same for this code smell. If it seems like two methods or classes are always talking to one another and should be together, chances are they probably should. If you have a method in a class that seems to like to talk a lot to another class to do its work, it may belong better within that other class. On a similar note, our next smell discusses the issue of when two classes depend too much on one another through two-way communication. This code smell is called inappropriate intimacy. Say you have two classes that talk really closely to each other, so a method in one class calls methods of the other, and vice versa. Should these classes be so closely coupled? Probably not. Likely there should be some way to remove this cycle. To remove the cycle, you can factor out methods that both classes use into another class. This might free up some of the close communication. At the very least, you should be able to make it so that the communication only occurs one way. Now, don't get me wrong, cycles aren't necessarily a bad thing. You may recognize that the state design pattern has cycles. There are going to be situations where these communication cycles are necessary. However, if there is a way to remove the cycle, that would be a good solution to make your design simpler and easier to understand. We previously talked about the law of Demeter, or the principle of least knowledge. That principle specifies which methods you're allowed to call. It's not just private methods you're not allowed to call. Even for public objects, there are specific rules as to when you are not allowed to call a method. The next code smell, message chains, potentially violates the law of Demeter. Say you have an object A, which has a method getB, and this returns a B object. On this B object, you call a method getC, which returns a C object. Finally, on that C object, you call upon it to do something. In this case, it could be that the law of Demeter forbids you from calling methods upon the B or C objects. Having these long message chains where you are calling, getting an object back, then calling again, getting another object is a sign that you may be violating the law of Demeter, and these are bad message chains. Bad message chains cause rigidity or complexity in your design. It also makes code harder to test independently. In order to find an object in the code, to get from A to C in this example, I have to navigate the chain and these objects' dependencies. You don't want to bake in a particular navigation to your objects. Let's say I want to rework my design and restructure those dependencies. If I do that, I'm going to break this code. That's a sign of a brittle design. That's not always to say that if you see a line of code with a chain of calls, it's a bad thing. Sometimes it can be fine. These message chains could be returning a limited set of objects that we are allowed to call methods on. If these objects follow the law of Demeter, then it can be a good thing. It's all circumstantial. Now let's talk about the smell primitive obsession. This is when you rely on the use of built-in types too much. These built-in types, or primitives, are things like ints, longs, floats, or strings. Now, obviously these are going to have to be used. However, they should only exist where possible at the lowest levels of your code. Overuse of the primitive types occur when you are not identifying abstractions and defining suitable classes. For example, you could conceivably just define or encode almost everything in your system as strings and put them in arrays. Your code ends up looking like something that was developed in the 60s. Back then, that's what you had to do. Since then, languages have evolved to allow us to define our own types for better abstraction, so you should be using that. Otherwise, you have a non-OO way of thinking. Here's an example for you. So here in Canada, we have postal codes. These may also be called post codes, air codes, PIN codes, or zip codes, depending on where you live. Basically, it's a series of letters and numbers included in a postal address for the purpose of sorting mail. In Canada, our postal codes consist of 6 characters, alternating letter, number, letter, number, letter, number. So they look something like this: T6G, 2R3. You could easily store this as a string and deal with it as such throughout your system. However, that's what we want to avoid here. That's because a key abstraction would be buried in the detailed code, and not very evident when looking at the design of the system, say in a UML class diagram. There would be no clear separation between a postal code string and other strings in the system. Would parts of your system care whether the postal code was all uppercase or had spaces? If you define a postal code class, then you can store the characters properly there. It would be much more obvious that this was a key abstraction for the system. You could also include various methods to validate it or calculate the region. If you find that you are using primitive types often at a high level, then that is a good indicator you are not declaring suitable classes and having a primitive obsession code smell in your system. The next code smell that we're going to talk about is switch statements. Now you may be thinking, what's wrong with the switch statement? Why do they exist if they're bad design? Well, sometimes there's a need to have big, long if-else statements in your code. However, there are times that switch statements could be handled better. For example, if your conditionals are checking on type codes, or the types of something, then there is a better way of handling these switch statements. Here in this example, the say method checks on the type of animal, and has different cases in the switch statement to have the animal say something appropriate, like woof if a dog. You want to be able to reduce these conditionals down to a design that uses polymorphism. In this improved design, we can have dog and cat objects that know the appropriate thing to say when their say method is called. Have you ever written any code with the thought, we might need this someday? If you have, you violated our next code smell, speculative generality. Speculative generality occurs when you make a superclass, interface, or code that is not needed at the time, but you think you may use it someday. Maybe you want the ability to make subclasses or provide a different implementation eventually, but you don't actually need it right now. If you're doing this, you are introducing generality that may not actually help the code. You are over-engineering the code. With agile development, you want to be practicing just-in-time design. You want just enough design to take the requirements for a particular iteration to a working system. So, at the beginning of each iteration, you would choose the set of requirements that are going to get developed. That is all you need to design for. You can ignore all other requirements in your backlog because those may never actually be needed. As you know, software changes frequently. Your client could change their mind at any time and drop requirements from the backlog. Your design needs to say simple. You don't want to spend time writing code that may never actually get used. When you need to generalize, then you generalize. This change may take longer at the time compared to if you set it up beforehand. However, you'll probably save yourself time overall across the system by not writing code that you don't need. It also keeps your code lean, simple, and easier to adapt. Finally, we're at our last code smell, refused bequest. This occurs when a subclass inherits something and doesn't need it. Think of this like your great-aunt Trudy has sadly passed away. In her will, she left you with her prized figurine set. She has hundreds of these little porcelain figurines that she had collected throughout her life. As much as you loved your great-aunt Trudy, you do not have the need, the want, or the space for these figurines. What was intended to be a gift has turned into more of a burden. This happens in code too. Say a superclass declared some common behavior across all its subclasses. If you find that your subclasses are inheriting things that they don't use or need, then is it appropriate that they be subclasses of this superclass? Maybe it would make more sense for a standalone class. Or maybe these unwanted behaviors should not be defined in the superclass. If only some subclasses are able to use them, perhaps it would be better to simply define those behaviors in those subclasses only. So those are examples of code smells. They are really great indicators of bad code and bad design. I recommend that you review your code frequently for those code smells to make sure that your code remains reusable, flexible, and maintainable. If you're interested in reading more about these code smells, or want to know what you're supposed to do in order to resolve these code smells, you can check out Martin Fowler's book, Refactoring: Improving the Design of Existing Code. Just like you can't write a good novel with one draft, you can't write good code without reviewing and adjusting the code to follow design principles, apply design patterns, and avoid code smells. Refactoring is a very important, yet sometimes overlooked way of achieving good design. Now go deodorize your code.
Congratulations! You've completed all the video content for this course. Now next up are the remaining capstone assignments. You've already analyzed and critiqued a working software product for code smells. Now it's time to make the code more flexible and reusable by using design patterns. They'll be followed by an end-of-course quiz that will test your knowledge from all of the material that we covered in this course. See you next time.